Welcome to the Icy Poles, my geography inquiry project. So, we have two poles on Earth, the North Pole and the South Pole. So, why do we need the poles? Well, most people would say the reasons what would happen if the poles didn't exist. But what is the purpose of them right now? Why do we need them as of now? Well, we need this for the albedo effects. So, water, snow, and dirty snow all has a property called albedousness. So, in this graph, we can see that open water has 7% albedousness. What that means is it reflects 7% of the light it receives and absorbs the rest of it, which means open water heats up a lot. And as we move down the scale, we can see that cold snow and wet snow absorb up to 85 to 75, reflect up to 85 to 75% of the light. And this is what the Arctic and the Antarctic are mostly composed of. So, because of this, 80% of the sunlight on average that strikes the poles is reflected. This is a very big effect because without the albedo effect, the world global temperature could rise by at least 10 to 20 degrees because these rays are not getting reflected and are instead being absorbed and trapped by greenhouse gases. The next reason we need the Arctic and the Antarctic is for these endangered species. Now, we will only be covering two of them, but more will be in the bibliography. So let's talk about the polar bears. Polar bears are the iconic figure for Arctic and the Antarctic. Whenever you think of the poles, you think of the polar bear. It's in the name. So why are the polar bears endangered? Well, they can't adapt fast enough to the changing temperatures. They previously adapted to temperatures such as negative 70 degrees Celsius and negative 60 degrees Celsius. That is one reason. And another reason is to do with the ice and their fishing and all their hunting zones. So, how do polar bears hunt for food? Well, all marine animals on Earth need oxygen. So, in the Arctic, there are holes in the ice through which marine animals pop up through. Polar bears will wait around that hole and camp it, and whenever a marine animal pops through, it will be ready to capture it and eat it. Now, with the ice melting, the ice moves farther inland, and therefore the marine animal has more space to escape and evade the polar bear. This means that the polar bear is not able to find food often, and its natural habitat is being destroyed. Next, we will cover the Arctic foxes. Now, the Arctic foxes are a very interesting species because although they are very small and compact, their small size allows them to trap the heat within their dense fur and survive up to negative 100 degrees Celsius in the Arctic and the Antarctic. This is a huge problem because the rising temperatures mean this species cannot adapt its body fast enough to those hot temperatures. The Arctic fox lives in the tundra or the desert of snow. And this is a problem because that desert of snow is being turned into a grassland because of the melting ice, and more flora and fauna are showing up. So this means the habitat for the Arctic fox is being destroyed. Another way we know that the Arctic is uh, being impacted by us is that Arctic foxes change the color of their coat to depict winters and summers. So in the summer, you will see this as a brown fox, but in the winter, you will see this as a white fox. And right now, it's incredibly rare to see a white fox in the winter because there's simply no reason. And brown, they change their coat of fur to blend in with the surroundings. So when there's more snow, they change their coat to white. So they won't be spotted as easy. So if there's no snow, they have no reason to change their coat. And that really tells you that we're melting them, the poles. Now, what's melting the poles? There's lots of reasons, but what's the main cause? Well, it's global warming. And what causes global warming? What is the root cause of global warming? These are just three main points that I believe is the cause for global warming. Now, automobiles. Each family on Earth has about 1 to 2 cars, and if you tally that up, that's almost over 1 billion cars. There's 7 billion people on Earth, and all those families together could really produce some CO2. And as we go further in the slides, in the statistics, you will see how much it takes to produce 1 metric ton of CO2. Now, fossil fuels and burning of coal and all. You might say that why can't we just shut these industries and directly move to renewable resources? Well, first reason is because our renewable resources are not as efficient as they could be if we actually tried. And the second reason is because multi-billion-dollar industries depend on this to survive. And if we destroy that, our economy could collapse overnight. Deforestation does not cause pollution, but it's a huge problem because trees remove the CO2 that we put into the atmosphere. And if we remove those trees, who's there to remove the CO2? And deforestation also causes a handful of other problems such as landslides and wildfires. So we'll move on to the next slide and see what is the effect. So they're melting. What can we do about that? Or why is it such a big problem? Why do we need to care? So right now, this is a glacier taken in Nunavut, province in Canada. So right here, we can see the 1986 photo, and we can see that the sea ice uh, reaches up to this extent. And we can, in 2011, we can see that the sea ice has retreated so much that these two glaciers don't melt. And this is a reversed heat map, so blue is bad, green is good. And you can see that there's barely any green left. So it's heating up. And what this means that the sea ice can come up till here. And what that does is it melts these areas faster and heats up the surroundings. Because as we saw in the previous slide, it showed that water absorbs more heat than it does reflect. It only reflects 7% of the light it receives. So if the water reaches up till here, all the surroundings will be heated up. So that is a huge problem. Next slide. And now we'll be looking at the poles directly. So in the Arctic, these are all taken by NASA, by the way. This was in 1979, and you can see that the sea ice forms this huge ice sheet that reaches Russia, some of Yukon, and Greenland. But in 2019, basically 30 years, the sea ice doesn't even touch Russia anymore. It doesn't touch Northwest Territories or Yukon, and it's only in Greenland and Nunavut, and barely Nunavut. It's only the islands. And this is a very interesting photo because this happened in 2020 February, and this happened in the span of 9 days. And you can really see what change brings when everybody's using when everybody's using their cars. This happened because of a wildfire in the Amazon, which released huge amounts of CO2, and that has melted all of this ice. So, and here we can see in the end of the photo, they're melt ponds. They're melt ponds. What are melt ponds? Basically, it's when water gets trapped in surrounding ice. So now you might be asking, what's the deal? Can it just freeze over? No, it can't. That's the problem because a lot of light strikes the Arctic and the Antarctic, and that's why they're able to reflect it. But if there's water there, the water will absorb that light, heat up the surroundings, and melt more ice, which is a huge problem. So these melt ponds are a really big problem. And plus, with these melt ponds, more snow cannot accumulate on the surface. Therefore, glaciers cannot grow, and the Arctic and the Antarctic will melt faster. sea level rise. So, as we all know, that if all the ice that melted, our global sea levels will rise by at least 65 feet. Some scientists predict up to 100 feet. But the world estimation is that it will rise by 65 to 80 feet. And now, in this video, we'll be looking at it later. This video explains what the cost is to defend or protect Lower Manhattan from just being flooded. New York, Lower New York. And in this video, they say that it takes over $50 million to protect just Lower New York. So can you imagine how much it would take to protect all our cities? And almost all of our mega cities are on the coastline, and they'll all be destroyed by this raising sea levels. Australia is also will incredibly be impacted because most of the coast of Australia will be destroyed, and that is where 80% of the people live. Only 20% lives inland. So will also face trillions of losses in trillions of dollars. Now, under the Arctic, there's a huge bubble or like column of methane. How much it has is 1,400 gigatons of methane. Now, why is this a problem? It's trapped in the Arctic. Well, you might think that, but no, the Arctic is melting, and this releases methane. Now, why is methane a problem? Because methane is a much, much, much more potent gas than CO2, like 20 times more potent. And as you can see, in the summer, the ice has thawed off and the permafrost has melted. And now methane is being released in these bubbles. So if the ice were here, it would trap that and the methane would never be released. But now since there's methane being released, that will melt the ice more faster and it will be an infinite loop. So it's an unpluggable plug. Now, in the Arctic and the Antarctic, there are things called subglacial lakes. What does that mean? Well, basically, under 1 to 2 kilometers of ice, there are underwater lakes where fresh water exists, and life that has never seen light for around millions of years lives there. Now, when a new species is being discovered, they generally classify it from known to unknown if the species is 90% different from the known species on Earth. And the microbial life, 3,500 genomes have been found, and and all of them are 86% different. Sorry for the technical issues. Right. So, as we know, there's 3,500 new genomes in the Arctic, the subglacial lakes. And one of the most popular lakes is Lake Vostok under the Antarctic, under 2 kilometers or 3 kilometers of ice in some regions. Now, how big is Lake Vostok? Well, Lake Vostok is about the size of Lake Ontario underwater. And so, when a species is being discovered, if it's 90% more different, then it's classified as unknown. And all the 3,500 genomes that have been discovered have been classified as 86% different. So we can really tell that there's unknown life in the lake. And some of the researchers that go into the lake and take a swim, not for research purposes, claim that the water is so pure that it looks like you're floating in air. You cannot see the water. And that really tells you how pure our waters could be if we didn't pollute them. Now, the change in currents and coral reefs. Alright, so the first change is that coral reefs will be deeply affected, and this will affect the whole ecosystem because small fish depend on these coral reefs for homes to survive, and predators depend on that, and humans depend on the predators for the fish industry. And if the coral reefs keep dying, the whole fish industry will collapse, and it will mean the end of our fishing ecosystem. And you've all heard of the Great Barrier Reef in Australia, and this is a photo taken in the Great Barrier Reef, and you can see that because of the Arctic melting, the water temperatures have risen, and it has killed this coral reef. And why does water temperature rising kill coral reefs? Well, because coral reefs are attuned to a certain temperature, and they cannot adapt to new temperatures. And the fish, depending on them, cannot go anywhere else. And this is a really big problem because as I said, the whole fishing industry depends on these fish to survive. And the next problem is the change in currents. So this is a huge problem because fishes depend on these currents to go up north and down south. And like birds, they also kind of migrate. Some fish live in these currents because it's just their natural home. And if these currents get warmer or colder, the fishes that depend on these currents will die out, and people depend on these currents for the fishes to come up north or down south, and that is a huge problem again because ocean currents endure massive changes while the Arctic and the Antarctic is melting. Now, more unpredictable weather and devastating weather. Well, hotter and later summers and warmer and later winters. We've all experienced this for our northern folks who experience winters with snow and later, and our tropical people who experience hotter and hotter temperatures every day. And why does this happen? Well, the first reason there's more unpredictable weather is because there are jet streams in our world or on our Earth that are responsible for carrying weather across the Earth globally. And the melting of the Arctic slows down these jet streams, and that is another big problem because the slowing down of these jet streams means that the high and low pressures in our atmosphere remain for a longer time. So thunderstorms will be longer, more devastating, and other weathers will be more devastating. The next is the storms. Why are they more powerful now? Well, let's take a look at hurricanes. Hurricanes will be more and more devastating because hurricanes depend on water to form. And if there's more water, the hurricanes are going to be bigger and more effective at destroying things. And landslides are also a huge problem. Floods will be there'll be more water, so more floods, earthquakes, and you can see it's a huge change that gets affected just by one place melting. Wildfires. So the hotter and hotter temperatures not only mean that okay, it's getting hotter. Let's take off my jacket. No, it means wildfires because as we know, the wildfires happens when trees rub their branches against each other and create sparks. And hotter temperatures will lead to more sparks being formed and cause a huge fire. We've already seen the Amazon wildfire and the Australian wildfire, and the Australian wildfire has a huge impact on its ecosystem. And the Amazon wildfire is really bad because the Amazon rainforest is home to millions of species and is one of our biggest carbon removers. And these two die out. Not only will there be no more plants to remove the carbon, but you can see that the amount of carbon that's being released from these plants dying will also lead to a rise in global temperatures. So again, it's a loop. More higher temperatures, more wildfires. Right. Now let's look at the proof. We can just say, all right, the temperature is rising. How much? And how do we know that it's rising? Well, here's the proof. Scientists have collected all this data from various points on Earth. So in 2000, we can see that parts per million, and this is related to CO2 emissions, right? So parts per million is the most common unit when measuring greenhouse gases or just gases. So in 2000 we can see there's like 339, and as we can see that in 2005 it slowly increases, and In 2019, we see this huge jump. That means our graph is not linear; it's parabolic. So as the year progresses, our graph is going to go up. Now, who are the biggest contributors to our world carbon emissions? Right. So the biggest contributors right now are China, US, and India. And we can see how much percent that they contribute to the world graph. And this is in 2012. So right now, we might have different contributors, or we might even have a higher percentage by certain countries. Right. So as I told you, we about automobiles, and right now, how much does it take for 1 metric ton of CO2 to be produced from your automobile? Well, for a mid-sized car, if you drive for 5,000 kilometers, you've already produced a metric ton of CO2. And this is also another weird comparison. If you have 20 cars idling, just sitting there on for 2 minutes each day of the year, you're already done. You already have 1 metric ton of CO2. So 5,000 kilometers, it might sound a lot, but for the amount of driving that people do just to get work or just recreational things, it becomes a small amount. And if you all look at the kilometer gauge, you can see that some people have 20,000, some people have 80,000, and that means you already burned through like four metric tons of CO2. Right. Now this is the unstoppable domino effect. As I told you that the methane release causes a huge loop. So global warming melts the ice, methane release. And you can see this loop keeps melting the ice. But it's not just a steady loop. The loop moves faster and faster as more methane is released. So and the global temperatures will also rise. Right now, the methane levels on Earth are nothing precedent to the amount that is under the ice. On Earth right now, we have about 40 to 50 gigatons of methane, but under the ice is 1,400. That's almost twice or thrice as much. And we can see the effects right here. The Arctic annual minimum sea ice testing. So what does that mean? Well, it means how much of the Arctic ice reaches a certain point before it slowly moves back due to the melting. So from 1979 to 1992, the average was 6.4% per decade. So that means it moved 6.4% backward. And 1993 to 2006, it moved 13.3% backward. And then in 2007 to 2020, it moved 4% backward. So we are slowly reducing our effects, but it's still not enough. And once it reaches a certain extent, we will not be able to stop it, and it'll just keep rising and rising. So that was the Arctic sea ice loss per decade. Right. So how much greenhouse gases and what percent are there? So in our atmosphere, we have our atmosphere for greenhouse gases only. 80% of it is CO2, 9% is methane, nitrous oxide is 6%, and fluorinated gases are 3%. And you see that the methane is now like almost 10%. But if all that CO2, methane that I was talking about gets released, this methane meter will go all the way up to here. That's almost 70%. And what can we do personally to stop the rise of global warming? Well, no matter how much we try to stop global warming, the ice will still melt. So we can only slow it down. So what we can do is walk where we can. You don't need to drive 500 meters to your nearest store. You can just walk there. Increase the efficiency of home appliances and other products. Believe it or not, on average, a household wastes up to 50 watts of power because they're not using efficient products such as LED lights. and power your home with renewable resources. You can use solar panels or other powers to power your home, and this also makes you money in return. So it's a free investment. Now, what can the world do as a global community? The world can slowly shift to renewable resources. Elon Musk, a great person, has already contributed to the world by introducing electric cars into our society. So you can make the small changes like that happen, and make them more efficient. So right now, our solar panels only are the most efficient solar panels can only get 40% of the light that strikes them. So it means they can only harvest energy from the 40% of light. So we can make that more efficient. We can make wind power more efficient. We can make geothermal power more efficient. And what else can we do? Well, we can plant more trees. It's literally in the nature. Trees are meant to suck out CO2 from our atmosphere. It's what nature did. So we could help that by planting more trees. Tax carbon heavily and promote eco-friendly products. Well, people right now don't want to buy electric cars or all that fancy stuff because it's expensive. It's not easy to get an electric car for most people. So what the government can do personally is to make that cheaper, and for people that have that use carbon, they can tax them heavily, which will make renewable products more enticing. Thank you for listening to my project, and that was my geo inquiry project on the global warming.